So let's begin by first discussing what an expression is. An expression is a combination of symbols and operators. Symbols are just numbers or variables, and operators are the things that you do with those symbols. Add them, subtract them, multiply them, or divide them. So this is an example of an expression, 6 plus 4. We are combining two numbers with this operator. This is another example of an expression. We are combining a variable with a number with the operator right here. And this is also an example of an expression. We have one variable which we are subtracting from another, and this variable is being multiplied by this coefficient. So let's discuss variables for a moment. A variable is a letter or symbol that represents a value that is not explicitly known. So here we have the number 4. Its value is 4, or positive 4 to be specific. But here we have 2 being multiplied by some variable x. We don't know what the value of this variable is, so it is not explicitly known. We do not know it just by looking at it. The letter x is often used as a variable, but any letter or symbol can be used. Hence, this expression, 4/3 z minus w. Both z and w, or any letter for that matter, can represent a unique value in the expression. So this is x plus 7, for example. It could also be written as q plus 7, c plus 7, so on and so forth. Now we have a few different components to these expressions. First, we have a coefficient, the 2 here, the 4/3 here, and although we don't see it, the number being multiplied by x here is 1. A coefficient is a rational number, an integer or fraction, being multiplied by a variable. So here we have 2 times x, 1 times x, and 4/3 times z. A constant is a fixed number in the expression not being multiplied by a variable. So in this expression, positive 4 would be our constant. In this expression, positive 7 would be our constant. And in this expression, we have one variable being subtracted from another, so we do not have a constant here. Now, an equation is created when you place an equal sign between two expressions. When an equal sign is between two expressions, the result is an equation. The two expressions on opposite sides of an equal sign have the same value. So here, if we combine the number 6 with the number 7, it has a total value of 13. So the expression on the left has the same value as the expression on the right. That is what the equal sign means. The opposite sides have equal value. It doesn't just have to be fixed numbers. We can have an equation that has a variable and a constant on one side, and we're stating that their combined value is equal to the value on the right side. When you're asked to solve an equation, what you're being asked to do is to isolate that specific value on one side of the equal sign and to place all the other values on the other side. So in the previous example, we had x plus 7 is equal to negative 13. Well, if we isolate x on the left side of the equal sign, we see that it has a value of negative 20. This can also be done with variables. If you are given a minus b is equal to c, and you're being asked to solve for a, if you isolate a on one side of the equal sign, we see that it has a total value of c plus b. Now, before we get to how to solve these, I first want to discuss balancing equations. Since an equal sign represents an equal value on both sides, whenever a constant is added to or subtracted from one side, the same must be done to the other side. So if we have an equation a plus b is equal to c, and we want to isolate a, we need to negate this positive b. Well, positive b and negative b have a combined value of 0, which allows us to remove this altogether. A plus 0 would just be a. But if we do it on the left side, subtract b, we must also do the same thing on the right side, subtract b. So we see that a is equal to c minus b. If we do not keep the equation balanced, here's what happens. Let's say we have 4 plus 5. We know that that equals 9. Well, if we want to isolate 4, we would subtract 5. But if we only do that from the left side, we wind up with 4 is equal to 9, and that is not true. But if we subtract 5 from the right side as well, we do end up with a true statement, which is 4 is equal to 4. All right, so remember, when you are solving an equation, you have to keep the equation balanced. Whatever you do to one side, you must do to the opposite side as well. Now let's discuss constants. Removing a constant specifically. If a constant is added to the same side as the variable, then subtract the same value as the constant from both sides to keep the equation balanced. So in this first example, a plus b is equal to c. If we want to solve for a, since we're adding b, we subtract b from both sides to negate the b's, leaving us with just a on the left side, and that's equal to c minus b. Another example, x plus 7 is equal to negative 13. Since we're adding 7 to the left side, we want to subtract 7, giving us a total of 0, so we can remove it, allowing us to isolate x on the left side. Since we subtract 7 on the left side, we must also subtract 7 on the right side. Negative 13 minus 7 would then be equal to negative 20. If we are subtracting a constant from the same side as our variable, then what we do is add the same value as the constant to both sides to keep the equation balanced. So negative b and positive b cancel each other out, leaving us with a is equal to c plus b. In this example, x minus 11 is equal to 5. Negative 11 and positive 11 cancel each other out, so we add 11 to cancel this negative. Since we add 11 on the left side, we also add 11 on the right side, leaving us with x is equal to 5 plus 11, which would give us 16. Let's have you try a few practice questions on your own. Solve for x in the following equations. Question number 1, x minus 5 is equal to negative 12. Question number 2, x plus 7/3 is equal to 5. And question number 3, z plus y minus x is equal to 49. Pause the video, solve these questions, and then press play when you are ready. Since we are subtracting 5 on the same side as the variable we want to solve for, we want to negate this negative 5 by adding 5, giving us a total of 0, and allowing us to isolate x on the left side. Since we add 5 to the left, we must also keep the equation balanced by adding 5 to the right side. So negative 12 plus 5 would give us negative 7. So x is equal to negative 7. Let's take a look at question number 2. Now in this one, we have a unique situation. The constant on the same side as our variable is a fraction. So if we want to subtract this fraction from the left side, we need the number on the right side to have a common denominator. So step 1, we want to convert the constant on the right side, which is 5, to the same denominator as the constant that will be removed, which is 7/3. You may remember, to convert a number to a different denominator, you multiply it by that number over itself. 3 divided by 3 is equal to 1. 5 times 1 would still equal 5. So we are not changing the actual value of 5. We are simply changing how we represent that value. So instead of the number 5, we represent it with 5 times 3 over 3, which would give us 15 over 3. So now our equation is set up nicely so that we can subtract the 7/3 in step 2. Subtract 7/3 from both sides of the equation. Positive 7/3 and negative 7/3 cancel each other out, leaving us with just x on the left side. 15/3 minus 7/3 would be 15 minus 7, which gives us 8/3. So the answer to question number 2 is x is equal to 8/3. And the last question, question number 3. Step 1, isolate the variable x by subtracting z and y from both sides. Since we are adding z and adding y on the same side as the variable we'd like to solve for, we want to do the opposite operation, which is subtraction. Z minus z would be 0, y minus y would be 0, leaving us with just negative x on the left side. Keep the equation balanced by subtracting z and y from the right side as well. So that leaves us with negative x is equal to 49 minus z minus y. And now step 2, remove the negative sign by multiplying both sides by -1. When you do that, -1 times negative x is going to give us positive x. Place this expression, since it has multiple terms, inside parentheses so that it's easier to remember that you have to distribute this -1 to each term inside of the parentheses. The -1 has to be applied to the entire expression. So -1 times 49 will give us -49. -1 times negative z will give us positive z. And -1 times negative y will give us positive y. So our final answer is x is equal to -49 plus z plus y.